So this unit is going to center around things being similar. All right, I'm going to compare it to congruent to start with because we've already talked about congruent and we hopefully kind of have at least a small remembering of what congruent means. So if I have things that are congruent, that means they're identical in that every piece from one shape has a specific matching piece in another shape that's the exact same size. So every angle matches an angle, every side matches a side. All right, that's how congruent worked. If we were just talking about similar, so two figures are similar if all of their corresponding angles are the same. All right, so what's going to happen is the sides are not going to be congruent. All right, they're going to be proportional. We'll talk about what that means as we go through and do some of the problems here, but that's what we're looking for. Important to understand is the symbol for similar. You're going to see this. All right, now that is the top of the congruent symbol. That symbol means similar, and it means angles congruent. All right, it means the angles match up. All right, so it says similar figures are the same shape but different sizes. All right, it's kind of like if you take a copier and you make something larger. All right, so if I have just really simple, a little picture here, a triangle that looks like this, and then a triangle that looks like this. They're the same shape. One is maybe twice as big as the other one. Right? There is one tiny exception to look for, and if you do take a Regents exam or a final or something, it loves to toss this in there every random once in a while. All right, figures that are congruent are similar, but their scale factor is 1. All right, not something to really stress out about, but it does kind of pop up every once in a while. Okay, similar figures have a scale factor, which is used in proportions. We're going to spend a ton of time talking about this. All right, so similar figures have a scale factor, which is used in proportions, two equal fractions to find missing sides. So it might say the scale factor is equal to, I'm going to write it two ways, 3:2 or 3/2. All right, and that means that the one triangle, the larger triangle is basically 1.5 times bigger. 3 divided by 2 is 1.5. But we'll use these in proportions and we'll cross multiply. As kind of another little quick example here, I might have like 3/2. I know that one side is 22 and I want to find that, and I'll cross multiply. So we're going to do a lot of that to solve the sides, not the angles. The angles are congruent. Okay. Similar triangles can be difficult to deal with because we've been having a lot of equal things, a lot of things that add up to 180 this far in the year. All right, and now we're going to start playing around these proportions, which we really haven't used much other than in trigonometry, but in trigonometry is kind of its own unique little ideas there. So pay attention to these. If you get the idea of setting the proportions up, when to do it, all right, you can have set up quickly, then it's not too bad to deal with.